There's two main deductive reasoning laws we're going to talk about, and the first one is called the law of detachment. And here is a definition for the law of detachment. If the hypothesis of a true conditional statement is true, then the conclusion is also true. Boy, that makes the whole thing seem complicated. Let's take a look at it in terms of an example. So here we have a conditional statement, and we're going to assume for argument's sake that this conditional statement is true. And here it is. If we have a test tomorrow, then Nick will study. So this does not mean that we have a test tomorrow, and this does not mean that Nick is going to study. It simply means that if we have a test tomorrow, then Nick will study. So we've got our true conditional statement that's below. Now, what it says is if the hypothesis of a true conditional statement is true, then the conclusion is also true. So let's say the hypothesis is true. Whoops, that's not the hypothesis. The hypothesis is true. We have a test tomorrow. We can conclude because we have a test tomorrow, Nick will study. Notice the hypothesis is true. That means the conclusion is also true. But here's where students get confused. What happens if we say Nick will study? What does that guarantee? Does that guarantee if the conclusion is true? Does that guarantee the hypothesis is true? Well, it doesn't. Nick could study for lots of reasons. Nick could study because he likes studying. Nick could study because his parents are making him study. Just because Nick studies does not guarantee that we have a test tomorrow. So, when we can guarantee the hypothesis, the beginning part of a true conditional statement, when we can guarantee the hypothesis, that guarantees that the conclusion is also true. If we know we have a test tomorrow, then we know Nick will study. But if we guarantee the conclusion, Nick will study, that does not guarantee the hypothesis because there could be lots of reasons that Nick might study. Let's take a look at one more example of the law of detachment. So here's a conditional statement. If there is a snowstorm, then we will not have school. We're going to assume that this conditional statement is true, and we won't worry about the beginning part. This is true no matter what. All right. So this doesn't guarantee that there's going to be a snowstorm. It doesn't guarantee that there's not going to be school. It only guarantees that if there is a snowstorm, then we will not have school. All right. So let's guarantee the hypothesis. So there's a snowstorm. If we know that there's a snowstorm, that guarantees that we will not have school. So by guaranteeing the hypothesis, it follows that we can guarantee the conclusion. But what if instead of guaranteeing the hypothesis, we guarantee the conclusion? We will not have school. Well, does that guarantee that there's a snowstorm? No. There's lots of reasons we might not have school. Maybe it's a Saturday or Sunday. Maybe it's summer vacation. Maybe there was a power outage in the building due to something completely different. The bottom line is only when we guarantee the hypothesis, when we guarantee the beginning, do we end up also guaranteeing that the conclusion will be true. We could guarantee the conclusion is true. That doesn't guarantee anything about the hypothesis. Okay?